the goal to find the point P. P is in the order pair form x comma y with the line is given as y equals 5x. Key term closest to the point 78 comma 0. After we find the point, so what is the least distance between point P and 78 0? From this information, if we draw, we don't have the diagram or anything. You just use information as y equals 5x as the line with the slope 5. Don't have to get a perfect one. So this is a line y equals 5x. And we're going to find the point on the line that is closest to the point 78 comma 0. X is 78, y is 0. So that point is somewhere on the x-axis. So 78 comma 0. And the point P is on the line. We're going to find the order pair x comma y as a point P located on the line that give the shortest distance. Okay. Find the point and then find the least distance. The key term, the least, that means the minimum value. Distance, that's the one that you're going to form the objective function. So objective to minimize the distance. So look for the equation for the distance between two order pairs. The first order pair, x comma y, second order pair, 78, 0. As you recall the distance formula, d is the square root of the change in x, which is x2 minus x1 squared, plus the change in y, y2 minus y1 squared. Okay, so from the objective function, let's see, d equals square root the two order pairs. If the first point is the x comma y, the second point is 78 comma 0. So x2 minus x1, we have x minus 78 squared plus the y minus 0 squared. Or we have square root of x minus 78 squared plus y squared. D as a function in terms of x and y. This is not the complete form for the objective function. So set it aside so far that what we got. And then for the constraint, what the constraint? The constraint gonna tell you the relationship of the two unknowns. Our unknowns in this problem right now, we have x and y, right? The two variables. Now we're gonna use a constraint to see the relationship of the x and y. What relationship that we have? Since the order pair x comma y is on the line y equals 5x. So any value of the y is 5 times of the x value. So that is your constraint. You guys have questions? No? Okay. So then with the constraint y equals 5x, the d is the distance, the shortest one from the point P to the point 78 comma 0. Then replace the y with the 5x. Now the function d is square root of x minus 78 to the second plus 5x to the second. We have the objective, we have the constraint. So what is the interval of interest? In this case, x and y are the values on the line, and the line y equals 5x. X can be any number. That means y can be any number. Or we can say this is a polynomial function and no constraint. So that means x and y, or based on the function d or the objective function, that down to the function in x. So x will be any real number. Will be any real number. Okay. That's the interval of interest. So we don't have the left and the right end. And what we have to do next is to find what x value that give the least distance. So least distance, that means minimum value of the distance. So we're gonna optimize it by finding the critical value using the derivative. So this case, you have the square root, you have the power 2 inside. You can expand the terms in the radical, or you can treat it the way it looks by using the chain rule. So either way, okay, either way. What I would do this one as the 25x squared, but I treat this as the, what do you call, the chain rule as x minus 78 raised to the power second. Just keep it the way it is. So the d prime, which is the derivative, so many d here. How about I change the letter d here as a capital D to be different than the derivative notation. So d. So this is d. Okay. So the capital D prime is the derivative with respect to x of the x minus 78 squared plus 25x squared quantity 1/2 power. Okay. Find the derivative using the chain rule. 1/2 of the whole quantity to the power negative 1/2, and then multiply by the derivative of the inner function. Okay. I'm gonna need more room, so let me manage this a little bit. So then the derivative of the inner function would be, for this part, I treat it as 2 multiplied by x minus 78 to the first power times 1. As chain rule, the outer is power 2, the inner as x minus 78, and then plus 50 times x. And then I can see the last factor here has the common factor 2. So I'm going to need 2 multiplied by x minus 78. And the leftover from the 50 that we take the 2 out, going to be 25x. Okay. As I factor 2 out, I can reduce 2 and 2, the top and the bottom. Now my numerator becomes x plus 25x, which is 26x minus 78, divided by square root, which is the power negative 1/2, will be the denominator with the square root. X minus 78 to the power second plus 25x squared. So case 1. So the d prime equals 0, which means 26x minus 78 equals 0. So x equals 78 over 26. Okay, and get the number out. It's a calculator. That comes out to be, oops, where did it go? Come out to be very nice number, 3. And the bottom one, which is the d prime undefined, we pretty much toss this case away. D prime undefined, or the denominator is 0, or x minus 78 squared plus 25x squared equals 0. And usually when you do this, the easiest one you could do, instead of expand everything out, you can do like, take it x minus 78 x squared equals negative 25x squared, which is not going to happen because the power 2 here always make the number positive. So this case will not happen. Okay, so then we just ignore the case of d prime undefined. Now we have down to one critical number, which is x equals 3. So if x equals 3, the relationship of the y and x as y equals 5x, because the other pair is on the line y equals 5x. Therefore, if x is 3, so the y is going to be 5 times 3, which is 15. Then the other pair, the point P as the other pair x comma y is in the form of 3 comma 15 as a point on the curve. And then the next part of the problem asks you to find what is the least distance between those 2 points. Now you just go back to the equation of the D. Either use this version or use this version, either one, to get the value out. So since we already got both x and y, so I'm gonna go ahead and use the one that has y in the equation. So oops, wrong color. So then the least distance gonna be the d equals the square root of 78 minus 5 squared plus the y squared, which is 15 squared. And then put in the calculator. Let me check the number real quick. Be 73 squared plus 15 squared, which give us the square root of 55, 54. And give us about 74.5 as the distance between those 2 points.